Hey guys, happy Monday. Today we're going to continue our lesson from Friday where we started looking at the absolute value function and the square root function. Um, and we also looked at the squared function and we started looking at what you can do to the function. So Friday we looked at how you can shift a function from left to right and also up and down. Today we're going to look at how you can do some other things to one. So if you were not here Friday, this is awaiting you in the catch-up bin. So go ahead and grab that. And if you were here Friday, we're just on the back side of your notes. So you also need a calculator, so make sure you grab one of those. So what we're looking at on this graph is just the basic absolute value function, so absolute value of x. And if we want to graph it on our own, we can do that as well. So you go to your y equals. Remember, to access absolute value, you hit math over to num, and then the very first option is absolute value, and then you just type x. And to see it, you just hit graph, but if you want to see a table of values, you hit second graph in order to access the table. So there again is exactly what we're seeing here, and if you wanted to see the table, you can see it right there. Okay. For some reason, if your calculator is not in like a 10 by 10 zoom, if you hit zoom and then option 6 is standard, it will put it in that 10 by 10 if it wasn't already. Okay, so that's what we're looking at. So now what we're going to look at is what if we change the function by multiplying it by 4? So I'm going to keep the original one, but then I'm also going to include this one. So on my calculator, keeping the original, I'm going to go down and I'm going to do 4 and then times the absolute value of x. So math num absolute value x. So I have the original and this new one, and then I'm going to graph it. There's the original, and then there's the new one. Okay, so you can see something definitely happened to it. So I want to be able to fill in this table of values so that I can graph it a little more accurately on this piece of paper. So I'm going to go second graph to access the table, and I want from -2 to 2, it looks like we have on here. Okay, so take a minute and do that. So it looks like I have 2, 1, 0, 1, 2. So then when we graph that, we have -2, 2, -1, 1, 0, 0. And if you want to get, whoops, I'm graphing the wrong one. See, this happens when you do things. Okay, so if you notice, I was actually just graphing this one all over again. So this is actually a good lesson here, and I messed up. Notice y1 was where just regular absolute value of x is. y2 is where the new one is. So if you're looking at the table, I actually need to be looking at these values right here because these are y2. Now, if that's too confusing, you can go ahead and get rid of the very first graph, and then you'll only have the new value. So that might be less confusing. So that's clearly it got me. So now I'm actually going to write the correct ones, and then I should see the correct graph. So this actually should be at 8, 4, 0, 4, and 8. And that makes sense because if I did plug in like 2, for example, for x, absolute value of 2 is 2. 4 times 2 is, in fact, 8. So that is actually correct. I had it wrong before. So there's my first point, second point, third, and then you can see it's kind of like the same thing on the other side. Okay, so if you do not have a straight edge, which I don't believe you do, the side of your calculator is a great resource for that. Okay, and this one was called g of x, so that's how I'm going to label it, just like right here. Okay, so that's what I want you guys to do for the next two. So go into your y equals, you can clear out the other one if you want. So you're just doing this new one. So the new one's h of x, which is 1/2 absolute value of x. So you can do it as 0.5, or remember to get a fraction like that if you hit alpha, and then y equals which doesn't work on my calculator because it's ancient, but it does work on yours. So you can do that. Alpha y equals enter, or just do 0.5. That works as well. Then absolute value again, so math num absolute value. And go ahead and take a look at that one. Okay, so that's our next one. So that's h of x. So now I'm going to go through and put those points in there and then eventually do the same thing for this. Okay, so if you want to pause or if you want to kind of slowly do it with me, at this point, I'm just going to take a couple minutes and graph these next two functions. I feel like there needs to be elevator music playing or something. Okay, so I have my original and then these three new functions all on my graph. If you're not done, go ahead and pause the video so that you can get those done. But again, clearly some different things are happening just by what number we put out front of the function. So I want you to think about what happened to the graph g of x compared to the original. So how would you put into words what happened to g of x? Good, so maybe you said something like it got narrower or skinnier, something along those lines. And then similarly, but also not, what would you say happened to h of x compared to the original? So here's the original, and then this one right here below it kind of was h of x. So how would you put into words what happened to it? Good, so maybe you said it got wider, kind of like pushed down almost, something along those lines. And then the last one, kind of a couple things happened to j of x when we had this -2. So how would you put into words what happened between this original one and this one right here? Good, so it also did get a little narrower. Not as narrow as g of x, but it did get a little bit narrower. But it also did what? Good, it flipped over. So it flipped over which axis, the y or the x? The x, good. So we would say more formally that it reflected over the x-axis. And that comes from the negative. So we can see here that when you're multiplying any function, we today are just using the absolute value function, by something, it looks like here, like when we did 4, it got narrower, skinnier, whatever you want to call it. Forget the negative for a second. When it was 2, it still also got narrower. But when we had something like a half, it actually got wider. So that seems to determine what's going to happen to it. And then the negative we saw reflected it over the x-axis. So let's kind of summarize all that. So in general, when you have a function, so any function, and you multiply it by any number, so k is just whatever that number is, if k is bigger than 1, so that was like this, for example, okay, we say, okay, that the graph is vertically stretched by a factor of k. So what that means, it's almost like pulling really, really tight, so it would get skinnier because you're pulling it really, really taut. And again, you saw that that means that the graph looks narrower. Good. And then we saw if k is between 0 and 1, so that would be like h of x here. That is what we call a vertical compression because it almost gets like pushed down. So it gets vertically compressed by a factor of k. Okay, and again, it looks like it's being like pushed down, so it looks a little bit like we saw, like wider. All right, and then the very last thing, when it was negative, so if it's negative, the graph is reflected over the x-axis. Okay, so now you guys have a few examples to try where you're combining this with what we learned on Friday. Now, I don't have all of that with me here, but for example, this is not on your paper, but just kind of watch this before you move on to the rest of your paper. So for example, if I said that I had function f of x, however, these things happened to it. It shifted right 2 units. It shifted down 3 units. It was vertically stretched by a factor of 5, and let's say it was reflected over the x-axis, and it became function g of x. So the question is now, what would an equation be for g of x? Now let's say f of x was the square root function, so the square root of x. So we took this, we did these 4 things to it, and now I want to know what would the equation of g of x be. Okay, so let's talk about what that would look like. So g of x, we're going to start with the basic absolute value of x, because that's what it was. Remind me from Friday, how do we show that it shifts to the right 2? So right and left is inside of the function, and remember, it's opposite what you would think. Normally we associate right with positive, but right is actually negative when you're talking these shifts. So we would show that with a -2 on the inside of the function. Okay, so we got that. How would we show that it goes down 3 units? Good. On the outside of the function, you would put -3, because down is exactly what you would think. It is minus. And then vertically stretched by a factor of 5, we just saw that today. That's when you multiply the function by something. So out front, I'm going to multiply by 5. However, it's also reflected over the x-axis. So this 5 becomes just a -5. Okay, so that would be the function g of x. Okay, so you, I believe, now have a few examples where you're asked to do just this. So take a basic function, do all these things to it, and then see what the result is. Okay, remember, if you have questions, please do email me. Remember, tomorrow you're going to learn one last thing. Again, email me if you have questions. Wednesday you'll review, and then Thursday is your Unit 5 test. And Thursday, your Unit 5 packet is also due. So just kind of keep that all on your radar. Hope you have a great Monday. Yeah, and I'll see you soon. Bye.